intercept missiles today, basically. Maybe not quite there yet. Did you hear how he said at one point X, Y, Z? Mm-hmm. So we have the X-axis and the Y-axis, and then there's a Z-axis coming out. That's how you do 3D, right? So you can say so much over, and then so much out would be a point in three-dimensional space. Oh, freaky. Okay. So what we're going to get into eventually today is called systems of equations. Maybe I'll do this. Yeah, I'm going to do this chapter 4 first, and then we're going to come back to section 3.8. We'll do section 3.8 after this. So today and tomorrow, we're going to finish chapter 4, and just that section 3.8 is left over from chapter 3. You guys with me? A little bit. Chapter 4 comes right off of our line stuff that we did, solving equation stuff, so I feel better doing that right away. So all that stuff is a little bit fresher. So let me ask you guys to help me remember this. If I give you an equation like this, how many answers are there to this?
Two possible.
Infinite number of answers, right? So, and it's because I don't have enough information. So if I told you that my age and somebody else's age, when you add them, you get 60, do you have any idea how old either one of us are? No. I mean, there's a whole bunch of numbers that add to be 60, right? I have to give you more information. So look at it this way. How many things do I not know? Two. So I need two pieces of distinct information to figure this out. So I always look at this like trying to solve a murder, right? You have all these things you don't know. Who could have done it? When was it that it happened? Where was this guy? Who's this? So you try to get more and more information to figure out all those unknown things. Okay. In math, if I have two unknowns, I need two pieces of information. 3, 4. So if I give you one more piece of information, there's got to be a way to figure out what the answer is. So this is what's called a system of equations. Not system of a down, sorry. System of equations. Yes?
Would X be 6 and Y be 5?
Could be. How'd you figure that out? Just by a guess and check? Okay. Not a bad idea. I mean, you can imagine a few answers to this, and all you really need are the two numbers that are 1 apart from each other that add to be 11. You guys see how that says that? They have to add to be 11, and they have to be 1 apart from each other. So the only two numbers that do that are 6 and 5. That's the only answer to this system. So that has an infinite number of answers. That has an infinite number of answers. The solution is going to be what works in both. So graphically, what would happen? Where would the answer be if I graphed both of these? So I graphed this first one. What can somebody tell me anything about this first dude? Is it in a good form? Good. I love it. So number 1, let's work with it a little bit. Subtract x. So what can you tell me?
It's going to be negative 1 over 1.
Jesus, Jeff. No, see, Jesus. I like it. So the slope is down 1 over 1. Is that cool? Right? Because that's what this here. You can kind of give yourself a few ones. There's all those understood ones just waiting to be shown. Right? Oh, look. Spotlight. What else can you tell me?
That's a slope.
Y-intercept is? 0, 11. Okay. So 0, 11. And then I go. So if I ever have to solve a system of equations by graphing by hand, I'm going to do more steps than normal. So what do I mean by that? Down 1 over 1. Pop. Down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. Get over there. Down 1 over 1. Oh my God. All right. Even that not be enough, so we'll see. Okay. Now what about, let me see, 1, 2, 3, 4. Oh, wait. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good job. What can you tell me about this guy? How do I get this guy in that same form? Yeah, I can subtract x, sure. And then I have to divide by -1. So you get y equals x minus 1. The signs just change, right? So then what do I know about that line? Yep, the y-intercept is 0, -1. That's where I start. And the slope is 1 over 1. So slope start at -1. Up 1 over 1, 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 up 1, oh my God, thank God. Now, so, if when I graph a line, it goes through, it's a visual representation of all the answers to that equation. This one is a visual representation of all the answers to that equation. So what works in both is where the lines meet, where they intersect. So they intersect at 1, 2, 3, 4, 5, 6, 5, which is the answer. Let me stop here for a minute. So all you need to be able to do for section 4.1, which is systems of equations and graphing, all you have to be able to do is graph 2 lines and then see where they meet. Now, if you just graph 2 lines and you don't do all the steps like I said to, you're going to be like, what the hell point is that? You're not going to be able to tell. How can I tell that so easily? Because I stepped a lot. And then I stepped a lot, and then I can see exactly where they meet. If I just put 2 points and draw a line, it ain't going to be straight. It's not going to meet somewhere nice. You kind of follow. I'm doing this by hand, so I got to be a little more precise. And for me, that means a lot more precise. So we get the idea of this. If I have 2 equations, they both have an infinite number of answers, but together they might have just one answer. Now, what else could 2 lines do besides meet at a point? What could 2 lines do? 2 lines could do this. And if the answer is where they meet, and they're parallel, what's the answer?
0.
If the solution is the point where they meet, and they don't meet, there is no solution. There you go. I like it. Your answer must always be what the solution is. And there is no solution, you just say, no solution, right? There's one more thing they could do, and this one's kind of dumb. They could lie on top of each other. In which case the answer would be, still is where they intersect. And if they lie on top of each other, where do they intersect? At all the points on the line. So that's, for example, that's like me saying, I'm twice as old as you are, and you're half as old as I am. Did I just tell you 2 pieces of information? No, that's the same thing. So I'm twice as old, you're half as old. I just said the same thing. Right? Y is 2x and x is 1/2 y. I didn't give you 2 distinct pieces of information. So those lines would be the same. I still don't know exactly what it is. Maybe. Okay. Here, you guys try this. Try to solve this graphically. What you got, John? That's a good chance. I like it. You're going to do a job. There, it has to be that. So try to solve that graphically. come out to a nice answer. So tell me something about this first guy.
Slope is 3 over 4.
Beautiful.
And the y-intercept is -0, -1.
0, -1.
Yeah.
And from there I go 1, 2, 3, 4. Sorry. 1, 2, 3. Over 4. 1, 2, 3. Over 4. That's a pretty big step. So hopefully that'll be something. This guy, the y-intercept is 0, 8. And then from there I go down 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Hey. So the solution is 4, 2. So as long as you're nice to yourself and give yourself a few more steps than you normally would, you can see a lot better where things hit. Right? If you just kind of like draw a line off of that, it could curve a little bit. And you're like, where the hell's that meeting? I have no idea. How you guys feeling about this? This idea works even with, you're going to need a little more help. If you had something that was on a trajectory like this, and it's going to come and strike something here, and I want to hit it with something before it gets there, I'm still going to want to figure out where those two equations intersect, right? So when you have those interceptor missiles and they're throwing the Scuds at us, and we get the Patriot missiles and all that kind of stuff, I'm thinking about the Iraq War way back when. I want to be able to calculate the trajectory that I'm going to need so I can hit that missile and destroy it before it destroys something else. Does that make sense? I mean, this whole idea of finding where two equations meet visually is exactly what you want to do in that situation. If there's a meteor coming, right, you don't have Bruce Willis to send up there, so you send up there a big rocket instead. Right? You guys know the movie I'm talking about? So real quick, here, in the book on page 48, try to do 1 and 2. So page 48, 1 and 2. So far, section 4.1 is really just the graph line problems from number 3. Just do 2 of them on a graph instead of 1. So if you're able to graph a line, you're able to graph another line on top of that. That's really the work involved. What can you tell me about this first line?
Slope is 2 over 1.
Yeah, slope is 2 over 1.
The y-intercept is 0, negative 1.
0, negative 4, I like it. So 0, negative 4, go, like you said, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I could even go down 2, back 1. Okay. And let's see if I can draw. Oh, it's weird on the edge of this thing. All right. And this other guy, what do you know about him? Slope is
Negative 4 over 1.
negative 4 over 1. The y-intercept is
0, 2.
0, 2. So you got a place to start, and then you go down
4.
1, 2, 3, 4 over 1. Hey, all right, didn't need all this stuff, so just in case. So what's the answer? 1, negative 2. Become a negative 2. Good Lord, Jeff. Right. There. A lot of people just graph it and they don't give me the answer. That's the most important part at the end there, is to interpret what the hell you just did. Yeah.
Why is it a negative
4? What is it now?
4?
So how do you get it over to the other side so you get y by itself? Cool. I have some people that like subtract the 4x, but then the negative goes on the 2. The only way that 2 can become a negative is if I multiply both sides by a negative. It's a positive 2. It better still be a plus 2 here. Okay. So you'll notice how crazy important solving equations is. If you have trouble with that, you'll have trouble with this. Is everybody decent with that? Is that... Okay. What do you notice about number 2 before you even graph anything?
They're going to have the same slope.
Yeah, they're going to have the same slope. So I know there's not going to be one answer. There could be no answers or an infinite number of answers. But notice the y-intercepts are going to be different. Yeah, so the first dude, you just subtract 2x for both of these guys. So they both have different y-intercepts. So the y-intercept of the first guy is negative 1. So you're negative 1. Down 2 over 1. Yeah. Oh, geez. And then the other one is plus 2. Down 2 over 1. So what's that answer? No solution. I love it. Kick your ass. How are we doing with that? Is that's all right? That's like one little baby step above just graphing one line. And I just got to graph 2 lines. Now, hopefully you understand, if the answer was going to be something like 3.198, 11.622221, am I going to get that answer by hand? Oh, shit, no. Right? So by hand will always start to falter when my answers start getting more real-worldy, right? More gross. I don't graph that well to see this kind of resolution. You guys, I don't graph well enough barely to see whole number resolution. Shit. So there must be an algebraic way to do this. So one of the first ways to do this algebraically is kind of freaky. We'll talk about it up here. Shapoop. Let's see. This is called, I'm going to do this way first just because this is the more important way. Elimination method. So the problem with either one of these is there's too many damn variables. The number of variables is too damn high. So I love elimination method because it's very direct. It says, let's kill somebody. Let's kill one of these stupid variables. There's a certain disbelief you should have about part of the process. Let me just do it and see if you guys see why there should be some disbelief. I'm just going to add these two together. I get x and x is 2x. Negative y and y is gone. 4 and 10 is 14. It's pretty cool with me just doing that. Some of you guys might have seen this before. Do you know why I'm allowed to do that, though? Am I not supposed to add the same thing to both sides of an equation? What did I add to this side? I added 10. Right? And what did I add to this side? I added x plus y. So on one level, you should be, why am I allowed to add two equations together? Why would that be allowed? Well, because 10 is x plus y. Right? That's what that guy says. 10 is x plus y. So if I add x plus y to this side of the equation, and I add 10 to that side, I am adding the same thing to both sides. So you are allowed to just add two equations together. If they're both true, the result is still true. How you guys doing? Do you guys get that? I do. I have to add 10 to both sides, but 10 is this. So I am allowed to just go ahead and line them all up. Now, why was it smart for me just to add them the way they are? Because one of the variables cancels. I love it. So this is a really easy example. Now, how do I keep going? So I know x is 7. How do I figure out what y is? Plug it in. I'm going to plug in 7 for x there. Subtract 7. Y is 3. Now look, I picked that one, didn't I? Could you have picked this one? Of course. So if you put 7 in for x here, 7 minus y equals 4, minus 7, negative y on negative 3 divided by negative, I still get 3. Because the fundamental idea is it's where these two meet. It doesn't matter which one you use to get the other piece. They should both agree. It's the point where they meet. So technically I'm okay if you give me x is 7, y is 3, and you circle both. But really, what should the answer be? Yes, the answer should be 7, 3. Because the answer to a system of equations is the point or points where they meet. But if you just stop here, I'm cool with that. I'm fine. But that is technically the right answer. That point 7, 3. How you guys doing? Yes? Yes?
So what we just did on number 1 and 2, we could do that?
Totally. Except for the instructions. So you got to be careful. There's a whole section where they say solve by graphing. If I were you, I might do this just to see what the answer is going to be so I know I'm on the right track with the graph, right? But you got to show me the graph work if it says solve by graphing. And you know on a test or quiz I would say solve by graphing, yeah. All right. God, I can't read you guys today. Glad we're not playing poker. All right. So here, look on, let's see. I think I went ahead of section. Yeah, there we go. Page 52. Try number 1 real quick. Oh, that's freaky. I was like, I'm a ghost. I forgot to. There I am. Right. This one is exactly like that one, right? Baby steps. So what do? Yeah, add them together. So when using elimination, I'm never going to add them together if none of the letters cancels. Because the whole purpose of this and the other algebraic method we're going to talk about in a minute is to get rid of one of the letters. There's too many freaking letters. Let me get rid of one of them, right? So at one level, this should feel really nice. You're killing letters. So when you add these together, you get 2x equals 12. So x is 6. And then you can choose either one to plug it in. I'm going to choose this one. So even if you chose the other one, you should still get the same answer. You can check it by using the one you didn't use. 6 minus negative 2 is 6 plus 2 is 8. Check. It's got to work in both. So this is acceptable, but what's a better way to write it? That point, 6, negative 2. That's the point where those lines would meet if I graphed them. Now before we get to this one's a little bit of a step up. I'm going to use this space over here to make my 1b. I'm going to do a little intermediate step to get us to the next level. So here I got, let's do, what do you got, Jeff? I don't know, man. 2x minus 3y. Let's make it work, Jeff. That'd be nice. Negative 1. And then negative x plus 4y equals 3. I like it. You know what? Kind of sucks about this one compared to the other one, besides this is in my handwriting. If I add these together, does anything cancel?
No.
Damn it. Right? So what do you have to do? Yeah, what do you wish was here, for example? I wish a 2 was there. I can't just put a 2 there because I want there to be 1, but I can do what to this equation? I can multiply both sides by 2. Anything you're allowed to do into an equation, you could do on these problems for each individual equation. If I multiply this guy by 2 on both sides, what do you get? Negative 2x.
Plus
8y equals 6. Let me rewrite the first one down here again. Now I've put it in a form that something will die. If you combine things and there's still x and y, you've done nothing good. You haven't gotten anywhere. You want to get rid of one of the letters. There's too many flipping letters. So here, of course, when I add these, those go away, I get y equals 5. So y is 1. And if you plug that back into like this first dude, 2x minus 3 times 1 equals negative 1. 2x add 3 equals 2x is 1. Together. Right? Take the one you know, put it back into either one of these to figure out the other dude. How you guys doing? You alright? I can't read you guys at all. Alright, well you I can read. Somebody in the back going, yeah. Alright. So what the shit do I do here?
You divided 2, the bottom you divided 3. I multiply.
Oh, okay, I like it. Alright. So it becomes like a like denominators idea. I've got to change both things. So if you want to get rid of the x, there's a slight problem. One of them's got to be negative, so the lines actually cancel. So the y might even be a better choice because they're already opposite signs. When you start doing stuff with negatives, you know that introduces a whole new area of places you can make mistakes. So normally I say, okay, which ones are already opposite signs? Let me work with that one. But it doesn't matter. It doesn't matter which letter you kill first. So if I kill the y's, we'll do it both ways. If I kill the y's, what's the LCD, or what number can 4 and 5 both become? 20. So I'm going to multiply the first dude, let me call him 1 and 2. I'm going to multiply the first dude by what? By 5. So times 5. So if I multiply by 5, I get 15x, 20y, oh shit, negative 110. The second one I multiply by what?
4.
Not just, yeah, 4, you're right. Just 4, Jeff, it'll work. What's 4 times all this? 8x plus 20y equals 64. So now when I add them together, something actually cancels. 23x equals Can you guys hear that? What classes going on? I don't know. Yeah, 46, negative 46. I knew we'd get there. And then divide by 23. Thank God 23 goes in evenly. Negative 2. So then you plug that negative 2 back up in here. One of these. You could use these, but why would you? They're the same as this. So if I plug it into this one, 2 times negative 2 plus 5y equals 16. That's negative 4, so add 4. 5y equals 20. Divide by 5y equals 4. Okay. So you get things to the point where when you add these equations together, something dies. One of the variables goes away. Why is that good? Because then I can solve for the one that's left. Once I got a number, I plug it in back up here, either place. Why does either place work? Because it's where they both meet. They're both going to say the same thing. Okay, all right. All right, I'm just going to stop trying to read you guys. So, and what's another way I could write this answer here? Well, yeah, let me make sure. Yeah. So negative 2, 4. That's another way you can write the answer. If you just write these, I'm okay. Circle those up. Or you can put them together as a point. Kick ass. Okay. So you guys try number 3. You should notice something pretty quickly about this one. So one thing is you got to multiply by a negative, right? So if I took the first dude and multiplied him by negative what? Negative 2. So I get negative 4x minus 8y is negative 10. And when I add these together, I get what? What do I get on this side? 0 equals negative 19. Is that true? When is that true? Never. So the answer is no solution. What's true about those two lines? They are parallel. I love it. I like it. Not equal. You're right. They never equal each other because they never touch. I love it. They're parallel. Kick ass. So that's how you tell algebraically a no solution answer. You get something that's never true. We know that from before. All right, let's do this last algebraic method, and that's enough for today, I think. So this method is called the substitution method. This is back on page 50. I kind of skipped ahead because elimination is more useful, but substitution you still have to know how to do it. So I'm going to ask you questions that are like specifically solve this using substitution, solve this using elimination, and then I might just say solve this, and you can use whatever method you like besides cheat. Now, you could use elimination, obviously, totally, but I want you to realize these are two pieces of information. So this first one tells me how x and y are related, and so does the second one. But notice the second one says y is negative 5x. So that means I can rewrite the first one. What? You use this information. So the first one then is x plus 3 times y. But what the hell is y? Negative 5x. That's why they call it substitution method. You solve one of the equations for a variable, and then you replace that variable with what it is. So x plus 3y equals negative 28. Now, this is I like elimination because it's very in your face. It's like, I will kill you now. Okay, you're dead. You're just dead. I just killed you. Yay. This one is more like Invasion of the Body Snatchers. It's like, replace you with this guy. It's very subversive, very kind of like behind the scenes. I don't know. I watched too many. I watched all the Game of Thrones. So I always have Game of Thrones math going on in my head. Now, how do I solve this?
Negative 15.
Yeah, x plus negative 15x equals negative 28. What's x minus 15x? Negative 14x equals negative 28. X is 2. And what's really nice about substitution method is I already have an equation that's solved for y. Negative 5 times 2 is negative 10. Okay. They always go to some freaky place after this. Here, let me make you a better number 2. Cross out that number 2. That number 2 is crap. Here's a better number 2. So again, solve using substitution. Oh boy, gotta make this work. Okay. Remember, solve using substitution, not elimination. Use substitution. So there's one little extra layer. What was so nice about this one was one of the equations was already solved for a variable. What's not true here, neither one is. But can you solve one of the equations for a variable without bringing fractions in? I love the facial expression, by the way. It's awesome. It's not helping me read anything, by the way. It's just because it's all over the place, but that's all right. So I give you a little hint. You can actually do this two ways, but can't you solve this one for x? Right? Why wouldn't you want to solve it for y? Because you're going to have to divide by 3 and make fractions. Why would you do that when you don't need to? So I find a letter that doesn't have any coefficient. Because I'm not going to have to divide by anything and make fractions. Does that make sense? I want to try to solve for a letter. So if I add 3y over, I know what the hell x is. So then I can rewrite this one as twice what x is, just like we did earlier. Substitute what x is. Now you could solve this one for y and plug it in there. It doesn't matter. It doesn't matter which way you go. Just solve for a letter and plug that into the other dude. Don't plug it into himself. A little questionable. You get weird answers. No Morse code. I think they're in trouble over there. Students are like, teacher forgot to take meds. Help us. So notice how elimination uses both pieces of information. It actually combines them. Substitution has to use both pieces of information. Use this guy to get X, plug what you got into the other dude. You got to use both pieces of information. So if I rewrite this, you get twice what? Yes, because X is 3y plus 2. Twice X plus Y is 11. So I rewrote twice X plus Y is 11, just replacing X with what I know. And why is this a better equation now? It's longer, but it's a lot better. Only one variable. I can solve for that variable, right? Get 6y plus 4 plus y equals 11. 7y equals 7. Y is 1. And once I know one of them, I just got to plug it in. So now I can plug it in that one because it's already solved. X is 3 times 1 plus 2. X is 5. Plug 1 in for y. Now you got what X is. Love that shit. Relative to some of the stuff we've done in here so far, this is not bad. This really isn't. You just got to get some practice with it. I can't read this. Oh man. Okay. That's really all I wanted to do today. It's awesome.
Great.
So tomorrow I'm going to have the practice test. If you weren't here last week, I moved the test back a day. It's on Thursday. I'm going to bring the practice test. I'm going to have your quizzes graded tomorrow. Give them back. We're going to do section 3 tomorrow, and then the next day is just review day. We're obviously going to do some more of these too, from chapter 4.
Can you explain number 3 again? I didn't get the solution.
So you multiply this first one by -2.
Yeah.
Now add these together. What do you get?
Is the test just going to be on chapter 4?
No, it's 3-4 through 4-3. Yeah.
So is that going to be the same for short notes too?
Yes. Cool. Wait. What happened? No. So now that's, you multiply this first dude by -2. Now add these two together. What's 4x minus 4x?
0.
What's 8y minus 8y?
0.
So on this side you get 0. -9 minus 10.
Negative 19.
And that's never true, so no solution.
Question. Do you have a code for me to add my step left?